We are now going to graph rational functions. And when we're graphing rational functions, it's really important that we look for the following. The first thing you should do is factor everything. And when you're reducing or simplifying your rational, it's really important that you remember any wholes. Anything that disappears from the top and the bottom is a whole and needs to not be graphed later. The second thing is to find the intercepts. The y-intercept is simply the last number on top and the last number on bottom divided by each other. And the x-intercepts will always come by setting just the numerator equal to 0. Once we have our intercepts, then you want to find your vertical asymptotes. And this comes from setting your denominator equal to 0. Then find the horizontal asymptote, if any, which involves comparing degrees. Then you want to kind of locate the graph. And by the way, when we're doing the zeros, we want to worry about multiplicities. And when we're doing the vertical asymptotes, we want to worry about multiplicities. And then once we locate our graph, then we can sketch it. So here's our first example, and I've got a few that I'd like to work through. Suppose we have f of x equals x squared minus 9 over x minus 3. Well, in this particular case, we factor this as x plus 3 over x minus 3, all over x minus 3. When I divide out the x minus 3's, I need to remember that x cannot equal 3. So on this particular line, x can't be 3, so whenever I cross this point right here, I'm going to leave a hole. So I've got a hole somewhere on here. But the line's going to pass over it because it disappeared. So we start our graph. Notice that now we just have f of x equals x plus 3. This is easy to graph. It starts here and goes up 1 over 1. When I get here, it's going to leave a hole, but it's going to keep going past that point and down the other way. And so we can draw our line like so. And that gives us our graph. And by the way, we're done at that point because that's all there is to it. We just have to remember that the x can't equal 3. So it was irrational, but it turned into a straight line with a hole. Well, what about this case? What if we have x plus 2, g of x equals x plus 2 over x squared minus 4. Again, we factor. And again, we have something that divides out, but this time we still have our 1 over x minus 2. Well, this means we're going to get a hole at minus 2, and we're going to have a vertical asymptote at 2. We don't have any zeros. There's no zeros because 1 never equals 0. And we have a y-intercept at 1 over minus 2. Just that one divided by that one, or minus 1/2. So we get a point right there. And that's what we need to worry about. So from here, notice that this is just our normal graph. But we have a hole right here. So we're going to come through this way, we're going to hit the hole, and then we're going to come out and then spit down and hug it. And we're just going to do the same thing over here, but notice that we never actually hit anywhere along this line, and we never hit anywhere along this line. So this is our answer here, because this is just moving. This is just f of x minus 2, which shifted our normal graph over 2, but we had to take into account our hole. Well, as another case, suppose we have h of x equals x squared plus 2 over x plus 2 x minus 1. Notice this one's already factored. So we can start by looking for our x-intercepts. When does x squared plus 2 equal 0? Well, when does x squared equal negative 2? It's imaginary, which means it never happens. There's no x-intercepts. So we never cross this line. Our vertical asymptotes are at minus 2 and at 1. Our degree on top is the exact same as our degree on bottom. If we multiply this out, we get x squared plus x minus 2, which will be important in just a second. So the degree 2 on top, degree 2 on bottom means our horizontal asymptote is actually here at 1 over 1, or 1. And our y-intercept is at 2 divided by negative 2, which is at negative 1. So knowing this information, I actually have everything I need to know to graph. I never cross this line. I never cross this line, at least not on the edges, I should say, and I never cross these. So my graph over here has to do something like this. That's not perfect, but it's the basic shape of the graph. It might get closer to here, it might be shaped a little bit differently, but that's where it's at. And since this is a multiplicity 1, when I go through the bottom, it's just going to pop back up on top, and it's going to follow and do something like this. And same thing, so this went through on the bottom, it's going to pop back up on the top, and it goes like this. So that's all I need to do to worry about my graph. Find my y-intercept, and that gives me my location. That's what we mean by location. And then just use the multiplicities to say it bounces through, or it passes through, I should say, or it bounces. And since these were all multiplicity 1, this is all that happens. We're going to end with one more example. Suppose we have x squared minus 1 over x squared minus 4, and this is v of x. Well, this factors as x plus 1, x minus 1 on top, and x plus 2, x minus 2 on bottom. That means my zeros come from the top. I've got a 0 at x equals 1 and at minus 1. Those become dots. I have vertical asymptotes at negative 2 and 2 from the bottom, so we're going to put in vertical lines here. Everything is multiplicity 1. I have the same on top and on bottom, so my horizontal asymptote is again going to be at 1. And my y-intercept is at minus 1 divided by minus 4, which is 1/4. So it's right about there. So this looks like it's going to do something similar to this. And since it's everything's multiplicity 1, it's going to pass through and it's going to come out on top, and it's just going to come over here. Same thing on this side. And it looks like that's my graph. That's close enough. That's the sketch that gives the basic shape of the graph with enough important points plotted that we know we're comfortable with it. So that's how we graph rational functions.